Hi everyone, I hope you're all having a great time. I know I am. I'm really excited to be here with you all. And today I'm going to talk about my work on tuning systems, and I will be presenting a prototype device that bridges Indian and Western tuning systems, along with a brief explanation of the concept and theory behind it. I promise not to be boring. So before I start, a little bit about myself. My name is Regina Balachanthiran. I am a French-born Sri Lankan. My parents were refugees from the Sri Lankan Civil War. During our time in France, they were worried about the cultural disconnect. And to compensate for that, we moved to the UK since my cousins and relatives also live there. So they put me through a lot of schooling and cultural activities as well that was available at the time. So during my weekends, I will be taught dance, music, vocal, other instruments, and Tamil language as well. So Monday to Friday, I go to school as normal, and then Saturday, Sunday is the cultural stuff. So that's how I started getting into South Indian classical music. I then moved to Bristol for uni. I did a degree in game audio and a master's in innovation and sound. And because of my background as an instrumentalist and performer, I wasn't comfortable and experienced with digital audio technology, but I found that I was surprisingly comfortable with the visual programming language that we were introduced to at the time, Max MSP, which allowed me to create digital audio technology. And one thing I noticed when trying to use my musical training with audio technology is that whilst there are some options for what I want to do with my music, it wasn't intuitive and easily accessible for me as well. So that's when I realized that the option I really wanted didn't exist, but it could. So um, before I show you what my device does and everything, I'm going to explain the difference I'm trying to bridge. And in order to do that, you'll need to understand these fundamental terms. So tuning systems is defined by the number of divisions and spacings of the frequency values within an octave. So it's kind of like the alphabet of a language, kind of, if you think about it that way. The next one is microtones. So in Western music, the octave is divided into 12 semitones, and the interval between two adjacent notes is referred to as a semitone, and anything smaller than a semitone is a microtone. The next term is a raga. So a raga is basically a scale with emotional content. So I guess it's similar to modes in Western music for those of you who are aware. And if you aren't, then it's a scale that carries a feeling or a mood. So the differences between Western modes and raga, I guess, it's that Western modes are used for compositional purposes and ragas are used for improvisational purposes. So you would improvise within the constraints of that raga. So it could be that a specific note glides in a specific way, or that the raga has grace notes or a motif to represent its characteristics and hue and color. The next term is shruti. So Shruti is an ancient Sanskrit word that's still used today, and it stands for a smallest interval of pitch that the human ear can detect. And finally, gamakas. I like to think of gamakas as the personifying element of Indian classical music, similar to the way we speak. If you think about it and take away all the intonations and inflections that we put into the way we speak, we will sound robotic, and that's what gamakas avoids. They are embellishments and beautifying elements of Indian classical music that connects notes from one point to another, and it may be a simple glide or a complex, shaky oscillation. So just to have a look at the differences between both schools of music. 12 tet is the tuning system, or 12 tone equal temperament, or 12 tet, or tempered scale, is the tuning system used in Western music since around the 18th century. This means that the octave is divided into 12 equal parts on a logarithmic scale, and the ratio of any adjacent pair of notes is the same. So since pitch is perceived logarithmically, it gives us an equal perceived step size, as opposed to 22 Shruti, which is divided into 22 unequal divisions and is microtonal by nature. Western instruments are designed around fixed pitch. Now, what I mean by that is that For example, C4, the note C4 is always going to be tuned to 261.63 hertz. And A4, for example, is always going to be tuned to 440 hertz. However, in Indian classical music, sa, which is the equivalent to C, if you like the note C, it's also the root note of the scale, is movable, which means it could be whatever pitch you want it to be, and the rest of the notes in the scale will be tuned relative to fit with the root note. 12 tet is also a compromised scale because the octave is intentionally mathematically compromised for it to work for things like key changes as opposed to 22 Shruti, which is based on simple whole number ratios, so also pure tones. In traditional Western classical music, polyphony and harmony is standard practice for musical compositions, which makes sense as a whole, because the whole equal division and intentional adjustments to the scale is so that you can have things like key changes, chords, and harmony. Whereas in Indian classical music, the focus is a lot more around complex monophonic melody and expression. So that's why you would have things like orchestra and ensemble performances in Western classical music, whereas in Indian classical music, you would usually have a soloist and an accompaniment of some sort if you have call and responses going on, or you also have a drone in the background to keep the pitch and the key at the same point, and a percussionist as well to make sure that the rhythm is going to. This is the diagram that shows how 22 Shruti is divided, just to give you a visual representation of that. So if you look at the first row, the 7 notes are Indian notes, and they can be compared to the Western 7 notes as well, C, D, E, F, G, A, B. So in Indian version, that's Sa, Re, Ga, Ma, Fa, Da, Ni, Sa, and that's why we have the R, G, M, P, and so on. The next row is also similar to Western notes. The structure is arranged in a similar way, and that's your C, C sharp, D, D sharp, E, E sharp. So we have a small R, a bigger R, and a small G and a capital G. So that's Re1, Re2, and all of that. So the structure is quite similar to Western classical music. But the next row is where Indian classical music is different. There are further divisions that aren't part of the Western classical system, where we've got a sharper variation, sharp notes, and then we've got sharper notes, and then we've got flat notes and flatter notes that are slightly tuned differently. So this diagram shows the positions of 22 Shruti notes and equal tempered notes to compare. So for example, if you have a look at A sharp and smaller N2, you can see that the positioning is quite further apart. So this means that in terms of tuning, you can hear the difference will be quite perceivable. Whereas if you look at, for example, A and capital D2, the positions are quite narrow and close together. So you won't be able to hear the difference in tuning as much, but in some notes you can. So theory aside, I'm going to do a little experiment. So I'm going to play 2 audio clips, and they'll just be simple sine tones. So please adjust your volume levels to suit you. And I'd like you to vote based on which one is the most satisfying. A, if it's audio A, B, if it's audio B, and C, if you can't tell the difference. I'd like you to use the poll function. So if I can have the poll function enabled, that would be great. Give you a couple of seconds. So that's audio A. And that's audio B. Can I see the results if they're there yet?
Them, but I'll tell you what they are. Audio A, we've got 52.11. Audio B, we've got 22.54, and a quarter, 25.35. I can't tell the difference. So winner there for Audio A, just over half the votes.
Ah, interesting. That's pretty interesting. So just for those of you who couldn't tell the difference, here's a visual representation in the form of an oscilloscope. So this shows exactly what you've just heard, plus an extra minor chord as well, just to give you another example of what it looks like. So that was just a visual representation of what it looks like. Next slide. Oh yeah. My device is, so just to have a look at how my device works. My device retunes electronic and software-based instruments from 12-tet Western tuning to a user-selected raga tuned to 22 Shruti assigned to the white keys. It also allows you to adjust the relative pitch to shift the frequencies up or down and still be in tune with itself. And to show you how it works, I'm just going to play this little demo that I prepared of my current prototype.
As you can see, I'm dragging in and dropping my prototype build into Ableton. I'm just going to turn the device off for now. For this to work, the pitch bend value that you'll find in the MPE tab of the instrument needs to be set to 2. So my device is very simple. It doesn't have very many complicated controls. At the moment, you can select from 5 preset ragas. You can also adjust the frequency of the root note. To demonstrate, I'm going to play Raga Bhairav with the device off and then the device on so you can see what it does. So here's the raga in equal temperament. And this is the 22 Shruti version. I'm now going to pick 2 notes of that raga and play them simultaneously with the device on and off so you can hear the tuning difference clearly.
Right, so I hope you could have you could hear that clearly. There was a little bit of lagging issues, but I hope that was fine for you guys. This is using MIDI, so I've put this prototype together using MIDI. Within digital audio, MIDI is the primary communication protocol that allows devices to connect and communicate with each other. And my plugin translates these messages into new messages with the correct pitch values. A little bit about Maximus P, the program I used. So I started out by using Pure Data first, which is on the left-hand side. It's a free open source visual programming language and it runs on anything. Through it, I built the structure of my idea and it worked in practice. but I was limited by the incompatibility of pure data with external digital audio software. The use of MIDI is also, in its nature, didn't quite allow the level of control required to microtune the incoming note messages. So I used MPE instead, which is MIDI polyphonic expression, an advanced form of the MIDI protocol that would allow me a finer control of the incoming note information and techniques for manipulating it. I also realized that pure data as an application was far too simplistic and unfriendly for implementing MPE, which led me to use Maximus P for the construction of my project. Maximus P provides more complex objects to program with for MPE processing and is integrated with Ableton, which allowed efficient testing of the plugin within a native musical environment and sped up the process by a couple of weeks. But it also brought its own set of challenges, such as not intuitively understanding the new frequency values for pitch. Since MPE is a new specification based on MIDI, there was a limited amount of resources out there, and that took me another few weeks to figure out, and I had to put together some complex maths and clever application of polyphonic voice handling in able to do it. I'd like to run through my purpose and goals for this project. So the first thing is accessibility. And now microtonality and tuning systems is a very niche area in music and is often perceived as a complex subject area. And I think this is mainly because microtonal tuning capabilities integrated into current music production tools require an understanding and awareness of non-Western tuning standards. Another thing is that mathematical calculations of pitch offsets also need to be accounted for, or relevant coding formats, which limit the accessibility to all creative and musical communities as well. So in the demo, you would have noticed that the plugin retunes the notes of a selected raga and maps it to the white keys on the MIDI keyboard. And this way, the tool is also accessible to musicians who have no prior knowledge of Indian classical music or piano. The next goal is preserving my history. So ancient traditions of Indian classical music have been adapted to Western tuning through the historic influence of Europe and India, whilst currently there is a resurgence in the use of the previous traditional tuning system. It presents its own limitations in terms of musical creativity and diversity due to the lack of software-based music making tools designed to utilize the Indian microtonal system naturally. And by adhering to traditional values of Indian classical music, I'm hoping to support the rising trend to the use of Shruti tuning in both the Carnatic and Hindustani communities as well. Modernizing cultural identity is another important goal of mine. For me, modernizing cultural identity by ensuring compatibility of my school of music with modern music making software is important, and also raising awareness of the existence of the 22 Shruti as well, because a lot of Indian classical musicians aren't even aware of the fact that a 22 Shruti exists. So through this project, I'm aiming to promote diversity, community, and connection. Future ideas and ambitions. So my future ideas and ambitions include standalone plugin. So I hope to finalize it into a version compatible with all digital music making programs, not just Ableton. The next goal is performance mode. So I'm hoping to incorporate this as a built-in functionality that supports performance along with a physical device for live electronic music making as well. Additional ragas. At the moment, I've only got 5 ragas in there as presets, but I hope to add more, and other educational features such as instructions as to how they are traditionally played so that they can be used by people who have no background in it as well. And a couple of other features that I'm just puzzling out and working on at the moment. And all these ideas and current developments directly support radio in the fact that this is how content is made. And I'm also aware that radio likes to air live performances as well. So hopefully the final version will be useful in that sense too. So my video showed you that I currently showed is a working demo and not the final version. So you won't find it online to download it or anything. But I am currently looking for people who can test it, provide feedback, contribute, and collaborate. So don't be shy and feel free to get in touch. And here is my contact details.